Water, water everywhere, still not a drop to be found. About 1.8 billion people globally will face very high water stress by 2025. At least 2 billion people use drinking water source contaminated with feces, which is very unfortunate because on the other hand, 38 billion liters of sewage water is wasted every day in India due to sky-high maintenance and manufacturing cost of sewage treatment plants. Another persistent problem is leakage in sewage pipelines, which causes sewer gas odors, decreased draining capacity of toilet flush, crack in the foundation, damp and mold spores. So what do we plan to do about it? 6E uses IoT to make water smartly come back to our houses. We have developed a solution not only to detect the leakages in the sewage pipelines, but also to optimize the sewage treatment so that you can easily and happily decrease 70% of your wastewater. 6E's smart membrane bioreactor technology reduces maintenance cost by 60%. Not only that, it saves up to 60% in aeration cost and gives the least carbon footprint. We plan on applying machine learning and reinforcement learning on the database to know the pattern of usage and provide data to the government. It's saving someone's life with your money, so want to make it larger on your pocket too. We present the concept of STP on lease. We will install an STP for your building and will charge less than 7 paise per liter.
When the submersible pump is turned on from the website, dirty water from collection tank enters the first tank, which is denitrification tank. The denitrification tank is an anoxic tank in which nitrogen dioxide is converted into dinitrogen by Anammox bacteria and released in the air. When the anoxic tank is full, water enters from anoxic tank to aerobic tank through overflow. The recirculation pump is a centrifugal pump which is used to pull water from the second tank into the first tank. The membrane bioreactor module, which is an ultrafiltration module, is placed in the second tank, which pulls water into the membrane through by suction pump. Vega AS1061 microprocessor is used to control all the pumps used in the unit as well as the blower. The blower pipe is placed in the second tank, which is aerobic tank, to enable dissolving of oxygen into the water as a food to the aerobic bacteria. This is pH regulation program centered at 7 pH. We use Vega AS1061 to turn on the relays for acid dosing pump whenever the pH of input water is basic. Chlorine dosing pump will be added to the last tank and thus the purified water can be obtained. In the MVP we are using acrylic tanks, but for the prototyping of pilot plant, we'll have to use MSFRP tanks, add a rotary mechanical screening for screening of solid waste, and an MBR module in the last MBR tank. The ammonium ion sensor as well as the dissolved oxygen meter will be mounted in the aerobic tank. When the ammonium level of the water increases, dissolved oxygen level must be increased by increasing the blower speed. When biological oxygen demand of the water increases, recirculation should be increased and thereby drain is decreased. This control loop mechanism will decrease the dissolved oxygen requirement and thereby decrease the power consumption and operational cost. Hall effect water flow sensors are embedded in source node as well as tail node. The change in differential flow between source node and tail node would be able to detect the leakage automatically. By performing machine learning on the sensor data, we will optimize the parameters of STP in order to obtain best feed water quality with minimum power requirement.